All right, so let's define one-sided limits. We'll start with the right-hand limit, or the limit from the right. So we write it mostly the same way as before, but we put a superscript plus after the c value, the kind of destination of x that we're thinking of as we're thinking about how the y values change. So here, if I'm approaching c from the right, I must be approaching from the positive infinity side, you could think of it. So I'm kind of imagining sliding along the curve and seeing how my y values behave as I move from larger x values than c towards c, but stopping infinitesimally close to c. Or you could do the same thing here, and then stopping there. So it doesn't matter if c is positive or negative. It doesn't matter if y is positive or negative. That plus here just means coming from the plus side. So that's the right-hand limit, or the limit from the right. So guess what we're going to write for the left-hand limit, and then draw some related graphs. Pause the video and do that. All right, so welcome back. You probably guessed we're going to draw x going to c superscript minus f of x. And in copying these graphs, we'd put c here, and we'd be imagining tracking the function values as you move in from the left toward the right, or in this one, be moving along that way. So let's write it again. This has nothing to do with x or c being positive or negative, or the y values, the f of x values, being positive or negative. So let's go try it out on a fairly straightforward problem. Ready? So let's say we have a function that goes like this. Here we are at 5, and we've got 6, 8, and then a solid dot up here at 9. Maybe this graph isn't to scale, but that's okay. What would you say is the limit as x approaches 5 plus of f of x? What would you say is the limit as x approaches 5 minus of f of x? And what is f of 5? Take a sec to think about all that. So I'd say the limit of f of x as x goes to 5 plus is what's happening as I'm moving this way. My dot is kind of moving down the curve here. So that is equal to a y value of 6. What about as I'm coming in from the left, limit as x goes to 5 minus, I would imagine coming in from the left, and my y values are increasing towards 8. So this would be equal to 8. And f of x itself, f of 5 itself is 9. Just that closed dot there. So the limit from the left can be different from the limit from the right, which is actually kind of why we're doing all this. So based on all that, what would you say is the limit as x goes to 5 of f of x? We would say that is a does not exist limit because what? Because there's a left-right mismatch. What if instead of that graph I had something like this? Same idea as before, where this was still 6 and this was 8. So f of 5 is now not 9 anymore, it's 6. How does that change things? it changes this. Now f of 5 is 6, but it doesn't change the left side or right side limits, and the two-sided limit still does not exist. So limit x goes to 5 plus, the same as before. Limit as x goes to 5 minus is the same as before. And the limit as x goes to 5 without a plus or minus, the two-sided limit, still does not exist. All right.